Good morning, this is Mr. Flint, and we're going to be looking at constant acceleration. This Segovia is just out in the hallway. She'll be back in just a minute. We are going over some problems that involve some kinematic equations, and you're going to be given those equations in your notes on constant acceleration. If you go look for those, there are several equations there. Let's take a look at some of the problems that we've handed out to you today and how we use those kinematic equations when an object is undergoing constant acceleration. So here's your first problem. An aircraft starts from rest and accelerates on a straight runway at a rate of 10 meters per second squared for 20 seconds. What is the speed of the aircraft at the end of this time interval? Well, when we start going through our guess method, let's look at our givens. What do we have here? It's accelerating from rest, and this is important, from rest. That implies that the initial velocity of the aircraft is 0. And it's on a runway and accelerating at a rate of 10 meters per second squared for 20 seconds. So what that is our initial velocity of the aircraft is 0. Your acceleration of the aircraft is 10 meters per second squared, and you have a time of 20 seconds. So now, what is the unknown for this equation? Well, your unknown for this equation is going to be the speed of the aircraft at the end, or what we call the final velocity, final speed. So we've got to figure out what that is. What is the final speed of the aircraft? So looking at your equations, we need to go find an equation that solves for final velocity but also has acceleration and time in it. So you'll find in your equations you've got the final velocity is equal to the acceleration multiplied by time plus the initial velocity. Well, if you look here, your initial velocity is 0. So we have no initial velocity. We don't have to worry about that. We just do the acceleration multiplied by time. So let's plug in our numbers for acceleration and time. Acceleration being 10 meters per second squared and time being 20 seconds. 10 times 20 is going to give us 200. And in this case, since it's a velocity, it'll be meters per second. If we look at those units right here, let's pull those units out and analyze those real quick. We're taking meters per second squared and multiplying that by seconds. So we'll see the seconds cancels out one of those seconds, leaving us with simply meters per second. All right, so let's look at B on this. It says, what is the distance traveled by the aircraft during this time interval? Well, we have the same given, so we don't need to relist those, but now we have a different unknown. So the givens were the same as over here, but we have a different unknown this time, and that is going to be distance traveled. We have no idea what that is. So let's go back, look at our equation sheet again, and now we've got to have an equation that has acceleration, time, and now we're going to be looking for distance traveled. So do we have one? Well, we do, and it actually uses displacement instead of distance. We can say the displacement of the object is 1/2 at squared. Then it has some other stuff in there. The initial velocity multiplied by time plus the initial position. Well, we know the initial velocity is, again, 0. So this whole thing cancels out. That goes away. And we're going to assume that the aircraft starts at the starting point. So your initial position would also be 0. Both of these things are 0 and go away. So we really are going to be focusing on 1/2 at squared. And a lot of times this equation gets simplified to displacement equals 1/2 at squared. So now let's plug in our numbers. Your acceleration being 10 meters per second squared again, and then your time being 20 seconds. And this is squared. Notice the square appears outside of the parentheses, and that is important. So we've got to make sure to take that 20 seconds and square it. So when you're using your calculator, make sure you hit that squared button for the 20. So let me show you what that'll look like. We have 1/2 of 10, which is 5. Okay, so we've got 5. And then 20 squared would be 400. All right, 400, and it'd be second squared now on the inside of that parenthesis. So that parenthesis should really be over here. Let me do a little bit of erasing because that is slightly confusing the way it looks there. So I'm just gonna get my eraser out, erase that real quick, rewrite it. That second squared appears inside. Okay, there. So now we only have 5 times 400, which is 2,000. And since it's displacement, we'll have meters. So again, if we focus on pulling out your units, that would be meters per second squared on the bottom times second squared over here. And second squared would cancel out second squares, leaving us with meters. So you can see the units for this would be meters. All right, so there is number 1. Let's go look at number 3. How long does it take a car to travel 363 meters when accelerating at 6 meters per second squared from rest? So let's list out our givens up here. We have 363 meters, and that would be some sort of distance or displacement for our object. And I'm going to use displacement here because that is what is used in our formulas. When accelerating at 6 meters per second squared, so we know acceleration is going to be 6 meters per second squared. And this is asking for how long. So that implies time, and that would be our unknown. We do not know time. So now we have displacement, we have acceleration, and time for this one. So let's go find an equation that has displacement, acceleration, and time. Well, it's kind of the same one that we were just using. It's not kind of, it is the same one we were just using. Displacement is 1/2 AT squared. So notice I've got the displacement in it, I've got the acceleration in it, I have time in it. Those 3 things tell me I need to use this equation here with displacement and acceleration and time. Listing out those givens and unknowns tells us what equation we need to be using. So if you're not doing that given and unknown part of the guess method, you're gonna always have difficulties trying to figure out what equation do I have to use. Use this guess method. All right, so now we have that, but it doesn't actually solve for time. So we need to rearrange this equation to solve for time. So I'm gonna get rid of the half first by multiplying both sides by 2. If I multiply this side by 2, and then over here, I multiply this side by 2, this and this, the 2 and the half cancel out. So now I've got 2x equals AT squared. Now I've got to get rid of the A, so divide out the A on whatever I do to the right side, I have to do to the left side. So now I've got T squared left over there, so 2x over A is equal to T squared. And a lot of times we like to rewrite it so that we have the single variable on the left side, so we'll put T squared is equal to 2x over A. Now if I take the square root of both sides, I'll get T on the left side, and the T being equal to the square root of 2 times the displacement over A. Okay, so that's all inside the radical. So now let's plug in numbers. T is equal to the square root of 2 times your displacement, 363 meters, over the acceleration, 6 meters per second squared. Okay, so that is going to end up giving me, let me see, I've got to do that on my calculator. 2 times 363 gives me 726 divided by 6. So T is equal to the square root of 726 divided by 6. And this is a 7. Okay. And that's 121. So T is equal to the square root of 121. If we take the square root of 121, we get 11. And it ends up being seconds. Now, if we go back and look at y with units, come back here, this 363 really is going to be in meters, and this is in meters per second squared. So if we just look at the units, we're going to be doing the square root of meters on top and meters per second squared on the bottom. Well, the meters cancels out, and that gives us seconds squared on the bottom, which is the same as flipping it to the top. So it's really the square root of second squared, which is seconds. And that's where we get that unit seconds from there. So your answer would be 11 seconds. All right, so let's look at number 5. Number 5, a car traveling to the right with an initial speed of 22 meters per second. So there's our initial speed. And must come completely to a rest. So that tells us a final speed of 0 meters per second over a distance of 44 meters in order to pass a brake test. So with our givens, we can list out some information. Here's our givens. The initial velocity being 22 meters per second, the final velocity being 0 meters per second, and then your displacement being 44 meters. And then it asks, what acceleration must the car have? So there's our unknown acceleration. So we've got to go find a formula with final velocity, initial velocity, distance or displacement, and acceleration. Well, that equation is going to be what we call our no-time constant acceleration equation, which is v squared equals 2 times the acceleration times your change in displacement plus the initial velocity squared. Okay. So what acceleration must the car have to do this? Well, let's see. We need to rearrange this formula to solve for acceleration. And since we're solving for acceleration, we're going to try and isolate that all by itself. And I'm just going to put a little square around that A. We've got to get rid of everything else on this side of the equation. So let's start here and get rid of the initial velocity by subtracting out. So go minus v naught squared on this side, and it goes away. And then we'll subtract out the initial velocity, v naught squared, over here. So that gives us the final velocity squared minus the initial velocity squared is equal to twice the acceleration multiplied by your change in displacement. So we know that the final velocity is 0, so we're just going to get rid of that now. So that gives us negative initial velocity squared is equal to 2a change in displacement. So the next thing that we want to do is get rid of the 2 and the change in displacement. So let's get rid of the 2 and the change in displacement. 2 here cancels out the 2 up here. Change in displacement cancels out change in displacement here. We'll do the same thing on this side. 2 times your change in displacement. All right, so your final formula for this will be your acceleration is equal to the initial velocity squared over 2 times the change in displacement. We've got to make sure that this is all negative at the end. So now let's plug in some numbers. Your initial velocity being 22, so we'll plug that in. And we have to make sure to square this over twice the displacement being 44 meters, okay? So then let's do some simple math here. 22 squared is going to end up giving us 484. So let's do 484. And the unit on that would now be meters squared over seconds squared. And then over 88 meters. All right, so 484